Welcome everyone. I'm Iftikhudin Ahmed and today I'm excited to introduce our project on hotel management. This presentation crafted by Team TURING is not just about managing a hotel, it's about revolutionizing the way hotels operate. We're diving into a comprehensive hotel management system designed to streamline operations and enhance guest experiences. Let me introduce the incredible team behind this project. Our team, Team Turing, comprises a diverse group of talented individuals, each bringing unique skills to the table. First, we have our team leader, Mohammed Abu Talha ibn Riyaz Hassan. Then we have Mara Taskin Aumane as design manager. Then we have myself, Iftikhar Ahmed, as UI UX designer. Then we have Labi Hassan as software architect. And then we have Mohammed Rafid Azraf Hossein as software architect. This system is a game changer, skillfully designed to streamline hotel operations. With the hotel management system, we are offering a suite of essential modules, including user authentication, efficient reservation management, smooth check-in check-out procedures, responsive room service requests, and comprehensive financial reporting. Our focus is on creating a user-friendly experience for both guests and staff, simplifying tasks from sign-up to payment management. Our goal: to revolutionize guest experiences, automate reservations, and boost operational efficiency, all while aligning with high-level specifications for a seamless integration. This isn't just a software, it's a step towards the future of hospitality management. Today, we also recognize the diverse group of professionals who play a pivotal role in the development of our hotel management system. This includes our dedicated software developers, the visionary system architects, the meticulous project managers, our thorough QA teams, the decisive stakeholders and decision makers, and the committed maintenance and support teams. Each of these stakeholders brings unique perspectives and concerns, ranging from technical implementation and architectural integrity to project efficiency, quality assurance, and long term system support. Their collective expertise and insights are integral to shaping a robust and effective hotel management solution. In developing our hotel management system, we carefully consider the unique concerns of our diverse stakeholders. Software developers are focused on ensuring implementation efficiency and maintaining code quality. System architects concentrate on the overall system design and its integration capabilities. Project managers monitor the progress and keep the project aligned with its goals. Our QA teams are dedicated to developing thorough test cases and understanding the system's expected behavior. High level stakeholders and decision makers seek a comprehensive understanding of the system's impact. Finally, the maintenance and support teams are crucial for troubleshooting, resolving issues, implementing updates. Each of these perspectives is vital for creating a robust and effective system. Our hotel management subsystem is meticulously designed for security and ease of use. It includes features like sign up, allowing new users to create accounts, log in, providing secure access to profiles and functions for registered users, and log out, ensuring user sessions and security. In the reservation management subsystems, we've streamlined the process of making reservations and optimized check-in and check-out procedures for efficiency and guest convenience. Each feature is tailored to enhance user experience and operational effectiveness in the total environment.
Thank you, Iftikhar, for the brief description of the subsystems. So let's move on to the use case diagram of the whole hotel management system. So in the use case diagram of the hotel management system, there's a design view which has the features that contains crucial use cases that basically defines the management system's functionalities. So let's include all the functionalities. So firstly, there are three actors. Those are client, hotel manager, and hotel staff. And the features are, first of all, to sign up, which enables the guest or the clients to create accounts for accessing the reservation and the booking features. And the login functionality allows the registered users, both the clients and the staff, to securely access their profile and perform various actions within the system. The logout feature ensures secure logging out or the termination of the user sessions. Then moving on to the reservation, making a reservation allows the client to reserve rooms for specific dates according to the vacancy, and for specific dates the check-in check-out functionalities are also introduced. So these functionalities are designed for the hotel staff to manage the guests' arrival and departure efficiently. So lastly, the room service request enables guests to request for different changes during their stay, different add-ons. And lastly, the last system, which is the subsystem, which is the generation of financial report, which provides valuable insights for hotel management to the hotel manager. So these are the 8 use cases which collectively form the backbone of hotel management system. So that it's a seamless experience for both the staff, manager, and the client. So for the next slides, I'll be discussing the 8 use cases, that is the crucial functional that introduces the crucial functionalities of our system. Now let's move on to the use case description of the first use case, which is the sign up. This is UC001. As we can see, in our third phase of the report, we selected 2 use cases, which is use case 1 and use case 4, to briefly describe the sequence and also the description, and also find the cyclometric complexity that you can find in the report. As you can see, that the guest will sign up and the system will present a registration form, and then it will move on to the guest, where the guest will provide name, email, password, and then create an account, and it will be passed on to the system, where the system will validate the information and there will be a decision. So if there are empty fields, it will alert the user and then present the form again. It will be a loop. But if there are non-empty fields, the user will create their account and the process will end there. So let's move on to the description. So the precondition of the sign up will be the guest will not be registered in the system. So the normal flow will be, at first the guest will select the sign up button, and then it will the system will present the registration form, guest will provide name, email, password, create account, and then system will validate. If there is any empty field, it will move on to the alternative flow, which alerts the user to fill all other fields and then present the form again, and if not, it will end the process, and the post condition will be no new account is created. Next, there comes the use case description of the login. So this is UC001, where the actors are the guest, staff, and the hotel manager. The precondition is the guest must be registered in the system. So the normal flow will be the guest will select the login button, and then a system will present the login form, and the guest will provide their email, password that they have already given in the sign up option, and then sign up use case, and then the guest will click the login button. But there is also a conditional flow. So the system validates the information, and if there is any validity problem, it will redirect the user to the home page. If there is no problem, it will direct to the home page, and if there is any incorrect data, there will be alternative flow 1. So alternative flow will be the system will alert the user that their email and the password is incorrect, and will present the form again. So the post condition will be the guest will be directed to the home page. Moving on to the use case description of logout. This is UC003, where the actors are the guest, staff, and the hotel manager, same as login. The precondition will be the guest should already been logged in and registered into the system. The flow is very simple. The user will select the logout option, and it will ask the user if he or she wants to go out or not, log out or not, and if the user clicks on yes, then it will be logged out of the system, and if it creates no, then it will go to the alternative flow 1, which is the user will be redirected to the home page. The post condition will be the guest will be logged out of the system. Then for the next use case description, we have making reservation, which is UC004. The actor is only guest here. So the precondition will be the guest should be logged into the system. The normal flow of event will be the guest will select a make a reservation button and like the option, and the system will display the available room types, and the guest will select the desired room type, check-in and check-out dates, and any additional preferences during the process. And then the guest will submit the form, and the system will validate if the room is available or not, if the reservation details are correct or not. And if it is available, system will confirm the reservation and will provide a booking confirmation email. And if it's unavailable, it will go to the alternative flow 1. Alternative flow 1 says that an apology email will be sent to the guest, which will mention that the room is not available. So the post condition of the positive result is the room booking confirmation email will be sent, and the post condition of the alternative flow will be an apology email will be sent. For the next use case diagram, we have the check-in use case, which is UC005 with actor of only staff, the system staff, and the precondition will be the staff should be logged into the system. So the what does the staff has to do for the normal flow? Staff member will go to their dashboard and will display a list of arriving guests for the day, and the staff member will select the guests to check in, the guest which has already come for check-in, and then the system will validate the room availability, if it's still available or not, if the details are correct or not. And then afterwards, if it's validatory, the staff will assign the room to the guest, and the system will generate an electronic key room key for the guest, and the post condition will be the room key the electronic one for the guest will be generated, and the guest will be considered as checked in. The next slide will represent the user description, the use case description of the checkout, which is UC006. So it will also be handled by only staff, who is the only actor, and the precondition will be the staff has to be logged into the system. Normal flow will be the staff will go to the dashboard of the system, and the system will display the list of departing guests for the day, and the staff member will select the guest to check out, because the guest who has come for checkout will tell their name and details, and the system will retrieve the guest's booking and charges for additional services. And then the staff member will record the checkout details, and the system will mark the room as a vacant room. The post condition will be the room is vacant and the guest is already checked out. Now let's move on to the use case description of the first use case, which is the sign up. This is UC001. As we can see, in our third phase of the report, we selected two use cases, which is use case 1 and use case 4, to briefly describe the sequence and also the description, and also find the cyclometric complexity that you can find in the report. As you can see that the guest will sign up, and the system will present a registration form, and then it will move on to the guest, where the guest will provide name, email, password, and then create an account, and it will be passed on to the system, where the system will validate the information, and there will be a decision. So if there are empty fields, it will alert the user and then present the form again. It will be a loop. But if there are non-empty fields, the user will create their account and the process will end there. So let's move on to the description. So the precondition of the sign up will be the guest will not be registered in the system. So the normal flow will be, at first the guest will select the sign up button, and then it will the system will present the registration form, guest will provide name, email, password, create account, and then system will validate. If there is any empty field, it will move on to the alternative flow, which alerts the user to fill all other fields and then present the form again. And if not, it will end the process, and the post condition will be no new account is created. The last use case description is generating a financial report. So it's UC008. The actors is only the hotel manager. The precondition is the manager has to be logged into the system. The normal flow is very simple. The manager will select the menu option and the system will provide menu for the management tasks. And then a manager will select generate financial report button, and the system will collect data related revenue, expense and occupancy rates, and then will select the time frame and report the parameters as per as the client. And lastly, the system will generate a financial report which includes the details on revenue, expenses, profitability for the stay period, and then finally in the post condition the financial report is generated. Now, let's discuss which architecture has been followed by us in this hotel management system. We have followed the MVC architecture pattern. I would give a brief description of the MVC, how it is represented in our system. So, the model in model represents the data entities, which is the user, reservation, room service, and the financial report. And for the view, it will manage the user service files for interface files for presenting the information. And finally, the controller will be the user input and system behavior, ensuring interaction between the model and the view. In this slide, we discuss about the component diagram of the hotel management system. As you can see, we have given a whole component diagram, and in this design view, our management system will adopt the MVC architectural pattern, which will provide a high level of overview of how the system's responsibilities are divided among its major subsystems. So the component diagram here will illustrate the interconnected component, including the view, which is the user interface file, and the web browser, which is the client's access point to the website, and the controller who will be responsible for managing user input and systems behavior, and models such as user, which is can also be client and also staff, and their reservation, room service, financial report, finally the database files.
Classes of each subsystem. The first one is user management subsystem. User handlers the controller manages the user operation like sign in, log in, log out, and the methods are like sign up, log in, log out, valid sign up data, and create guest account. Identities are the user. Attributes are user ID, first name, last name, password. Inheritance hierarchy are the manager, client, staff, class inherited from user classes. The second one is reservation management subsystem. Reservation handlers are the controllers of the subsystem and they handles the reservation. The method are the value reservation data, create reservation, and get room availability. Entitles with reservations and rooms, attributes of the reservations ID, guest ID, room type, check-in date, and checkout date. Hospitality service subsystem. Room service handlers are the controllers of this subsystem. Manages room service operation, methods are valid service request data, create service request, get service request status. Entities are the room service request, and room attributes are request ID, guest ID, request type, and request status. And the fourth one is financial report subsystem. This financial report handlers are the controllers of this subsystem, oversees the financial report of this operation, and get the primarily method, which is the get and display report details. And these are the financial report and managers. Attributes the report ID, report type, start date, and end date. Our system is made up of four parts, and each one does a different job, like sign up and log in, are examples of methods in the user handler class that handles user activities. In the user management subsystem, it has methods of validating data and features. For taking guest account, the managers, client, staff, classes, and all inheritance are from the user class, which stands for the customers. Reservation handlers is in charge of the reservation related tasks. In the reservation management subsystem, these tasks include validating reservation, checking to see if rooms are available or not. The reservations class holds reservation and is linked to the room class to show how booking are related to rooms that are available. The room service handlers leads to the hospitality services subsystem, which is in charge of room service operations like validation order and getting progress update. The room service request class handles calls for all room services. It is linked to the room classes. Each shows how it interacts with room availability. Financial report handlers is in charge of financial report subsystem, financial report progress, get and display report details in its main method. Get the show and gets and shows financial report information and financial report class for the financial reports, and it is linked to the manager class to show how manager are connected to the report creations. These classes and subsystems work together to make sure that our system can handle take reservations, provide room service, and support on financials. Factory pattern design. So here we'll discuss about abstraction of object creation, encapsulation of object creation logic, flexibility in object creation, scalability, and enhance of readable and maintenance. The reservation class handler is a great example of how to use the factory design pattern in the reservation management subsystem. This makes the system more flexible, scalable, and easy to manage. This pattern focuses on the reservation class and let you make the different type of reservation without showing the client how complicated without the complicated parts. Reservation handlers encapsulates creation code, which helps keep the design clean by acting as a factory because the method is flexible. It can handle new types of reservation also without changing the client code, which makes scaling easier as the system changes. It gets easier to add new ticket type and they are linked to the room classes. This method makes sure that different reservation situations are handled effectively, which makes the code easier to read and maintain it in a dynamic selection. The factory design pattern makes the room management subsystem more flexible, scalable, and easy to manage, especially in the user management subsystem. Using the factory pattern, the user handler quickly makes the client, staff, and hotel manager user types, hiding the process of creations and making sure the design is clean. The best thing is it is how flexible it is. You can easily add new types of user without changing the client code that's already there. The factory pattern makes it easier to add new types of user as the subsystem grows. Each each makes the code easier to manage. With this method, the user handlers is only one who knows how to create an object. The client code talks to an abstract user interface or base. The room management subsystem does more than manage users. It also makes sure that rooms are handled effectively. Room service handler class is in charge of room service operation, which includes making sure that data is correct. The Room service request class handles service requests and connects them to the available rooms. The concentrated prototype A and concentrated prototype B examples show how the prototype pattern can be used to make new objects quickly by copying the old ones. Overall, the room management subsystem makes good use of factory design pattern to help user create new things, focusing on things like separation, encapsulation, flexibility. Managing rooms takes care of room service, and prototype pattern is also work together to make the subsystem work better and more effectively. Now we are going to talk about prototype design patterns. Efficient object creation, dynamic object creations, reduced subclass profilization, enhanced customization, simplified client code, and scalability. The prototype design pattern is used in a financial report subsystem to create different type of financial reports. These methods use copies of current reports as prototypes, which is helpful when the cost of making something is high. The pattern allows of dynamic reports writing at runtime, which cuts down on the need of many subclasses and makes it easy to make changes. Clients get simpler code when they use prototype instead of having a deal with the application details. Scalability is guaranteed because it is easy to add new types of reports to some of the prototype pattern makes working with different financial report faster, more flexible, and easier to manage. The prototype design pattern is used carefully in the hospitality service subsystem to make it easy to make it easier to make requests for the room service. This pattern takes it easy for the system to use current objective as prototype, which cuts the cost of making new objective by large amount. This is especially helpful when room service requests have similar structures, which makes cloning faster than starting from scratch all over again. The prototype design also allows to create dynamic objective run different runtime, which gives the subsystem more option for handling different type of room service requests. Adopting this method makes sense because it keeps subclasses from becoming too common, make customization easy, simplified client code, and encourages scalability. A prototype is used for each type of room service request, so there's there isn't a need for a very complicated class structure. Getting beyond the subsystem of the hospitality service, managing user, the user handlers act as a factory for different types of users, like clients, staff, managers, using the factory design pattern. Financial report subsystem. The financial report handlers is in charge of all financial reports and makes sure that financial reports are made quickly and more correctly. Reservation management. The reservation handlers coordinates this task related to reservations, making sure that the rooms reservation goes smoothly. Room management and room servicers. The room service handlers in charge of this room service, which includes checking data and take care of the service requested. Together, the prototype pattern, along with other design pattern, the subsystem part is a key of making the system more flexible, easy to keep up with this complicated world of hotel management. Thank you. There are several important relationships in the hospitality management system. This includes staff managing multiple reservation, guests making multiple reservation on their own, reservation being tied to specific room is so many to one setup, and the starting multiple room service requests they are linked make it easy for staff guest, reservation room, and service requests to talk to each other and work with the system.
Hello, assalamu alaikum. My name is Rafid Emri Azrufushan, and I will talk about the user interfaces. So, sign up interface. Users can access the sign up functionality by selecting the sign up button, and a user friendly registration form will be presented promoting users to input their name, email, password, etc. And clear validation messages will be displayed in real time, guiding users to correct any input errors. And upon successful validation, users will click the Create Account button, triggering the system to create a new user account. Feedback messages will inform users of successful account creation or guide them through necessary corrections. So the next, the login interface. The login interface will provide users with fields to input their email and password. After entering credentials, users will click the login button. Real-time validation will occur, displaying feedback on the accuracy of the provided credentials. Upon successful login, users will be directed to their personalized dashboard. Now is the reservation interface. Users can access the reservation functionality from their dashboard. A user-friendly interface will display available room types, allowing users to select dates and preferences. Real-time availability checks will guide users in selecting suitable options. Confirmation messages will notify users of successful reservations. So this is the check-in and check-out interface. Hotel staff will access the check-in and check-out functionality through their staff dashboard. Streamlined interface will display arriving and departing guests, allowing staff to manage check-in and check-out processes efficiently. So this is the room service request interface. Guests can request room service through their dashboard. Menu will display available services, and guests can provide specific instructions. Real-time updates will inform guests of the status of their requests. So this is the hardware interfaces. The system will be accessible through standard hardware devices such as desktop computers, laptops, tablets, and smartphones, ensuring flexibility for users. And software interfaces are the system will interface with a relational database to store and retrieve data. Secure APIs will connect the web application to the database, facilitating seamless data transactions. So this is the software interfaces, database management system, server-side framework, web application framework, client-side framework, and operating system. And these are contents of name, mnemonic, specification number, version, source, etc. So the next part will discuss by Abu Talha. So that's all from me.
Hotel management system is organized into distinct subsystems, each encapsulating specific functionalities to ensure a modular and maintainable design. These subsystems include user management subsystem, reservation management subsystem, hospitality services subsystem, and financial reporting subsystem. User management subsystem contains classes such as user, user handler, manager, client, and staff. The user class serves as the base class with manager and client and staff classes inheriting from it. The user handler class acts as the controller managing user related operations. Reservation management subsystem. It contains classes such as reservation room and reservation handler. Hospitality services subsystem. It contains classes such as room services request, and room service handler. And finally, the financial report subsystem, which contains manager class, financial report handler class. The dependencies among these classes are as follows. The reservation management subsystem is dependent on the user management subsystem. The hospitality services subsystem relies on the reservation management subsystem. And the financial reporting subsystem operates independently but may access data from subsystem to generate comprehensive financial reports. In the first sequence diagram, SD001, which is the sequence diagram for sign up, the guest first signs up and then a sign up form is shown by the hotel management system. Then from the in the user class, the guest sets the first name, the guest sets the last name, the guest sets the email and password, and then creates an account, from which the user handler validates the sign up data and creates a guest account. And then the sign up functionality is complete. Second sequence diagram for sign up alternative, which is SD002, The guest signs up, and the guest gets the sign up form, and the guest sets the first name, last name, the email, and the password, and then creates an account. But here, the guest forgets to enter the password, to which the website alerts the user to fill all the information, and then the sign up form is shown again to the guest. The sequence diagram for login, where the user logs in and the login form is shown to the user. Then the user sets their email and password and clicks on login, which goes to the user class. And then after that, the user handler gets those information and then validates login credential method is used, and then the user is logged in. For the sequence diagram SD004 sequence diagram for login alternative, the user forgets to enter their email and then logs in, to which the website alerts them to invalid data, and then the validation is not complete. So the user handler throws the invalid error, and from which the login form is shown again to the user by the HMS. For SD005, which is a sequence diagram for logout, there are only two classes involved, the user handler and the HMS. The user first logs out, and then the confirmation of logout is sent by the HMS. If the user clicks on yes, the logout method is used, and the logout user method is used to log out the user successfully. For SD006, the sequence diagram for logout alternative, here basically the only change is that if the user clicks on no, the HMS redirects the user to the home page of the website. For SD007, the sequence diagram for make reservation, there are two classes, the reservation class and the reservation handler class. In order to make a reservation, the guest first clicks on make a reservation on the HMS, to which the reservation class fetches the data and sends the room type to the HMS. The guest then selects the room type, the check-in date, the checkout date, and then submits. From the reservation class, the validate reservation method is then run, and then get room availability method is then run. If there is true, which means if there are rooms available of that type and on those days, the create reservation method is then sent to the reservation handler in order for the reservation to be made. For SD00A, the sequence diagram for make reservation alternative, the only difference is that when the reservation handler sends false instead of true, an email is sent to the user, and that email is the apology email apologizing to the guest that the room is not available on that date, or that room type, that specific room time is not available. The sequence diagram for check-in, SD009. Here, the staff opens the dashboard in the HMS and gets the guest lists. Here, in the client class, the staff can select the specific client or by the set guest method. And then, from the client class, the get room availability method is then run, and then validate reservation method is then run. From there, we get the confirmation message that specific guest is actually already reserved a room. From there, the staff can then assign the room to the specific guest. For the sequence diagram for checkout, which is the SD10, we have the staff as the actor and two classes, client and HMDB, which is the hotel management database. From there, the staff first selects the dashboard in the HMS and gets the guest list. The staff then selects the specific guest, and from the client class we get the booking details by using the get booking details method. The details are sent to the staff. From there, the staff record the checkout details, and then set the room as vacant by using the set vacant room method. SD11, sequence diagram for room service requests. So there are two classes, the room service request and the room service handler, and the main actor for this sequence diagram is the guest. The guest first clicks on request service in the HMS, from which they get the services list. Then the guest requests the type of service they want, and then the request room service method is then run. After that, from the room service request class, the validate service request and create service request methods are then run. That's how the guest makes the room service request. SD12 is the generate financial report and the last sequence diagram of our system. This sequence diagram basically says how the financial report of the system of the entire system, hotel management system, will be generated. Basically, the hotel manager will only be able to perform this functionality or perform this use case. First, they will select the start date and the end date, and from there, the financial report containing the profits and other financial data will be sent to the HMS for the display of the hotel manager. Transition diagrams offer a dynamic view of the HMS, emphasizing the behavior, modes, states, and transitions, reactions to events within the system. The viewpoint is particularly useful for reactive systems and those where internal behavior holds significance. In the next couple of slides, we will be delving into the state transition diagrams for all the use cases, unraveling the dynamic nature of the HMS and shedding light on the intricacies of its behavior. First transition diagram for the sign-up system. The guest first selects the sign-up, and then the system provides the registration form. From there, they enter all the credentials, and from there, if the user is valid, then the new user is created. If the user credentials are valid, then a new user account is created. This is the alternative sign-up process transition diagram. So basically the thing that is different from the previous slide is that if a user keeps any of the fields empty, an alert will show up that tells the user to fill all the fields. After that, we have the state diagram for login. Here, basically, the user enters their email and their password, and if the credentials are correct, which are checked by the user handler class, then we get a valid user, and the user is then redirected to the home page. Login alternative: if the user enters any wrong email or password, the user will be first alerted that the details or the data they entered are invalid, and they will be redirected back to the login form page. This is the state transition diagram for the logout use case. Basically, if the user enters logout, the logout method will be run by the user handler, and the user will be successfully logged out of the system. After that, we have the alternative logout. Basically, in this state transition diagram, we can see that if the user clicks on no, then the user will be redirected to the home page of the system. Then we have the state transition diagram for make reservation use case. In this use case, basically how the guest applies for a reservation and how that reservation is then handled is shown by this in this state transition diagram. We then have the state transition diagram for make reservation alternative. Basically, in this diagram, what we can see here, if the specific room type or the dates in which the user check-in or check-out are not available, then an apology email is sent to the user. This is how the make reservation alternative is performed. Then we have the state transition diagram for check-in. In this state transition diagram, it is performed by the staff actor. Here, the staff checks in the guests that already reserved a seat in the hotel by using the HMS. So the user first checks if the user actually if the guests that arrived actually have a reservation. If they actually have a reservation, then the user assigns a room to them. After that, we have the state transition diagram for the checkout. In this state transition diagram, basically the staff confirms that first checks out the user, and then the reserved saves their booking details on the HMDB, and then confirm their payment, and then finally mark the room which they stayed in as vacant. Then we have the state transition diagram for the room service request. Here, the user or the guest basically applies for the room service and then selects the room service type, the type of service they want, and then send it to the HMS. And finally, we have the generate financial report state diagram. This is the last use case of the system, and basically this generates the financial data of the system. The hotel manager first selects the start date and the finish date, and then on those dates, the profit made and other financial data are then retrieved from the database and then shown into the HMS. For the algorithm viewpoint, we chose to show the code of the sign up use case in C++. As we can see that there are three classes: the user class, the registration system class, and the main class. From here, first of all, the user will enter the name email. Their name email will be checked to see if those email are if that email and that particular password is available on the system already. If not, then the user will be registered in the system, which means a new account will be created. If the user has all the fields filled, all the fields in the form are filled, then there will be no problems and the user will be able to create their account successfully. Otherwise, there will be an error which will say that all fields must be filled. Please try again. To conclude my part, this is the final point of the algorithm viewpoint of the code that was previously shown. This is the decision table, and the conditions are represented by the columns name empty, email empty, and password empty. The values are true and false, which indicate whether the respective fields are empty or not. The actions are represented in the action column, describing the system's response based on the conditions. If all fields are empty, true, 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 the system displays an error, and so on. So if any single field is empty, the system displays an error message. If no field is empty, false, 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 the system creates an account. Thank you.
Now let's see the user interface view. This is the sign up page for the sign up use case. People can use this page to sign up. This is the login page for the login use case. People can use this page for logging in. And this is the logout page for the logout use case. This is the make reservation page for the make reservation use case. This is the check-in page 1 for the check-in use case. This is the check-in page 2 for the check-in use case. This is the checkout page 1 for the checkout use case. This is the checkout page 2 for the checkout use case. The room service request page for the room service request use case. This is the general financial report page for the general financial report use case. This is the traceability matrix. These are the tools used. For documentation collaboration, we used Google Docs and MS Word. For use case diagram and component diagram, we used Enterprise Architect. For making package diagram, sequence diagram, and class diagram, we used Lucidchart and Draw.io. For making the interface, we used Wizard.io. Thank you for your attention and engagement. It's been a privilege to present the hotel management system developed by Team TURING. We hope this system not only captured your interest but also demonstrated the potential for technology to revolutionize hotel management. We're grateful for this opportunity to share our work with you. Should you have any questions or require further information, please feel free to reach out. Thank you once again for joining on this journey into the future of hospitality management.